Hello students and welcome to another video lecture on logic design. In this video we will continue to learn about binary codes. In fact, we will take a look at another category of numeric codes called as non-weighted codes. We have studied XS3 code in a previous video. In today's video we will learn about gray code. What is gray code? Gray code is a non-weighted code. That means it does not depend on a positional value of a digit. It is also non-sequential. It is a reflective code since, as we will see shortly, a n-bit gray code can be obtained by reflecting a n-1 gray code about an axis. It is also called as a cyclic code, which means every transition from one value to the next value involves only one bit change, or in other words, successive code words differ in one bit position only. For this reason, it is also called as unit distance code. Let us see how to write gray code. This method is called as the prefix and reflect method. So you start by writing 1-bit gray code, which is basically 0 and 1. In order to write 2-bit gray code, you start by writing 1-bit gray code, that is 0 and 1, and then imagine an axis of rotation and reflect this 1-bit gray code over the axis to get 1, 0. Once you have done this, for all the values above the axis, you put the MSB as 0. For all the values below the axis, you put the MSB as 1. Let us do the same thing to write 3-bit gray code. Let us start by writing 2-bit gray code. Then imagine an axis of rotation and reflect the 2-bit gray code over the axis to get this. Once this is done, for the values above the axis, you put the MSB as 0. For the values below the axis, you put the MSB as 1. In the same way, write 4-bit gray code by writing 3-bit gray code first. Imagine the axis of rotation and reflect the 3-bit gray code above the axis. For the values above the axis, you put the MSB as 0. For the values below the axis, you put the MSB as 1. I want to bring your attention to the cyclic nature of gray code. Consider the code 1110. Look at the code exactly below it, that is 1010. Clearly notice that the difference between the two codes is in 1-bit position only. Similarly, comparing the code 1110 and the code exactly above it, the difference you see is in 1-bit position only. This is the cyclic nature of gray code. Gray code can be converted to binary and vice versa. The technique is very easy and it requires you to recollect the logic of an XOR gate. If A and B are inputs to the XOR gate and Q is the output, then if A and B are 0, the output Q is also 0. If A is 0 and B is 1, then the output Q becomes 1. If A is 1 and B is 0, then output Q is also 1. If A is 1 and B is 1, then Q is also 0. For this reason, XOR gate is called as inequality detector. So with this revision of XOR gate, let's take an example. Given the gray code number 1001, let us find its corresponding binary code. Start by writing the MSB as it is. To find the next binary bit, XOR the first binary code bit with the second gray bit. So 1 XOR 0 is 1. In the same way, XOR the second binary bit with the third gray bit to get the next binary bit, which is 1. Lastly, XOR the third binary bit with the fourth gray bit to get the last binary bit, which is 0. Notice that the MSBs remain the same. Similarly, you can convert the binary code back into gray code. Taking the same example, convert the binary number 1110 into gray. Start by writing the MSB as it is. Now XOR the first binary bit with the second binary bit. We get the answer as 0. Now XOR the second binary bit with the third binary bit. 1 XOR 1 will give you the answer of 0. And lastly, XOR the third binary bit with the fourth binary bit. 1 XOR 0 gives you the answer of 1. Notice, even here the MSBs are the same. In this manner, you can find the gray code for any number. Simply convert it to binary and convert it into gray code. That's all for now. Gray code finds its use in rotary and optical encoders, those instruments where successive code words differ in 1-bit position only. Also, we will see its use in the plotting of K-maps or Karnaugh maps. Stay connected to the classroom for more videos and learning material.